Here is our automatic pet feeder. We created this mechanism to dispense pet food to ensure that the pet is well fed when the owner would be away and unable to feed the pet. We used SOLIDWORKS to design the mechanism and a 3D printer to fabricate and prototype the pet feeder. We used several mechatronics concepts in consideration for this project, and we have several components that include a RP2040 Pi Pico on a maker board, an ultrasonic distance sensor, a DC motor driven by an accompanying power unit, a 12-volt voltage regulator, and a force sensing resistor unit. The conceptual design for this project was to have a hopper store the food above the bowl and have the food funnel down into the bowl when it needed to be filled. We realized that regulating the flow rate of the food dispensed would be difficult to control, so we used a rotating wheel that would contain specific portions to be dispensed into the bowl. The hopper pours food into each compartment with every rotation of 180 degrees and dispense food directly into the bowl. In order to minimize food being stuck in between the wheel and the slot, we designed a chamfer on the lagging edge of each of the wheel's compartments. To implement the ultrasonic distance sensor, the mechanism was designed with the slot angle directly facing the bowl. This was to ensure that the pet was detected. In order to conceal the circuitry of our mechanism, we created an open space behind the structure. This allowed us to store and hide these components for a more cleaner look. Here's a view of the circuit of our automatic pet feeder. We have broken down the mechanism circuit into 3 segments: the weight sensor, the motor system, and the HC-SR04 sensor, which is the ultrasonic distance sensor. The weight sensing resistor varies between a 50 ohm to 200,000 ohm resistance depending on how much pressure is applied to the metal film. The more pressure put on the component, the less resistance the variable resistor will have. It has an exponential relationship, which is useful in our use of the weight of the bowl as a threshold. To measure the voltage with the sensor properly, we use the voltage divider utilizing 100,000 ohm resistor, using the 3v3 rail as an input and an ADC pin as the output. The second system, which is the motor system, is a motor that we are familiar with due to the fact that one of our lab assignments used the same variation. The DF Robot DC motor SJ01 with encoder was simple to use as we decided to use the motor end instead of the encoder. While the encoder did have the ability to accurately count the pulses and distance, we did not need the precision for this project and opted to use the stronger motor end to drive the large wheel on the chassis. This meant we only needed to drive the motor with 2 power leads. These 2 leads went into the L298 dual half-bridge motor driver and the output leads. Using the 2 input terminals connected to the Pi Pico, we were able to control the direction of the motor. The L298 is also responsible for driving 12 volts into the motor. The last system, which is the HC-SR04 sensor, was also straightforward, as all of its pinouts can go directly into the Pi Pico board. The echo and transmit pins go into their own GPIO, the VCC is fed by the 3v3 rail, and the ground is connected to the circuit's common ground. Thank you for watching our automatic pet feeder video. Hope you have a wonderful day.